So, usually we did. Oh, sorry. Wait, what is that thing? Went through this. So, I'm just gonna show you like the type of questions that are gonna come out when it comes to magnets. As you can see from question 9, magnets don't really have that many marks, but you just need to know about how they work and how their magnetic fields are constructed and stuff like that. So since we did magnets on on Tuesday, do you think you can be able to answer like this question 9? And yeah, we can just go through it together now.
Okay.
So I'm just gonna ask you the question, and then yeah. So they say the magnetic field lines between two magnet poles of a magnet are shown in the diagram. And as you can see, like you can see the directions of the magnetic field and the poles that are given. So the very first question they want you to, and then they just state to you that the magnetic force is a non-contact force, which is true because like the magnets don't have to be touching in order for them to experience the magnetic field force. So they say, can you determine? Oh, I just gave you the answer. Can you define the term non-contact force?
Must I define it?
Yeah, yeah.
A non-contact force is poles that do not touch each other in order to have a magnetic force.
No, with here we're talking about magnetic fields, but we have to talk about it in terms of a force. So, but yeah, I think you have to say a non-contact force is a force that is applied even though the two objects aren't touching each other, or a force that is not directly in contact with the object, because a magnetic field, you can't see a magnetic field with your own eyes, but you can visualize it. And when you see like two magnets pushing against or attracting each other, you don't see the magnetic field that, no man, these magnets are actually coming together. It's not like you're pushing them together, but there's this invisible force that you don't see, and the two magnets aren't in contact, but they still exert that force on each other. I think I have a problem of over explaining it, but either way, a non-contact force is a force that can be experienced even when the objects are not in contact. Objects applying the forces are not in contact. So they say give another example of a non-contact force. So can you think of any other force that, let's just say it's invisible, but it can interact with the two objects?
I'm not sure. I don't know. I'm gonna guess now. Is it radiation?
Uh, Radiation is light and energy. there's no there's no forces involved in radiation. But if you look at the force of attraction between the Earth and the Moon, you see, because if there was no forces attracting the Earth and the Moon, like you would not, like the Moon would obviously like go well further away from the Earth, or so you can actually, you know what, skip that. That's that's a complicated one. You see, let's just consider force of gravity. You don't have to be on Earth for you to experience the force of gravity of the Earth. So do you get the picture? Like you don't have to be in
Yes.
contact with the Earth in order for you to experience the gravitational pull of the Earth. So you can just say the Earth's gravitational pull. That's also a force that's non-contact in some cases, but yeah. Actually, I think in most cases because you can't see the gravity. And then they say, what is the nature of the force between the two poles? If you look at these two poles, are they attracting or are they repelling? That's basically what they're asking. Can you answer?
Is it repelling?
No. So basically, what happens when two magnets are repelling? Because I remember, I think I drew this for you. So remember what your magnet has your north and south pole, right? So I'm just gonna assume, actually, you know what? Let me just finish this. Let me just use this question. And obviously I'm gonna give the answer for the next question, but that doesn't matter. So you have pole one and you have pole two. If these two poles were repelling, the magnetic field lines would look something a bit like this, right? To show that there's a repulsion between the two poles, the magnetic field lines would not even touch. They won't touch. But as you can see here, they are actually touching. They are actually exchanging between one another to show that there's attraction. If there's repulsion, it's gonna look something like this, and the magnets will move further away from each other. So if it was repulsion, the magnets will move further away from each other. And since it's something like this, and the magnetic field lines do touch, then it's gonna be attraction. So when there's repulsion, it looks like that, and when there's attraction, it looks like this. And then they say, what is the polarity of pole two? So do you remember how field lines travel? How the magnetic field travels? Does it travel from the North Pole to the South Pole, or does it travel from the South Pole to the North Pole? Uh,
From north to south.
exactly. So when it's traveling from north to south, you're just gonna look at this and look at where the look at the direction of the magnetic field, and you can obviously describe whether pole two is pole 2 is the north or is it the south pole? By looking at the direction of the field lines.
Pole 2 is the north and pole 1 is the south.
Exactly. So you see, and for the reason that you must give is the reason that I gave you. I actually gave you the reason. The reason is you can look at the direction of the magnetic field lines. You can see the magnetic field lines indicate that the field travels from pole 2 to pole 1, meaning pole 2 must be the north pole and pole 1 must be the south pole. Or you can just say pole 2 and in brackets say north to pole 1 in brackets say south. Obviously, they know that magnetic field the magnetic field travels from north to south. So basically, this is the type of question that you're gonna be dealing with when it comes to magnetism. It's not magnetism doesn't really have that many marks, but that doesn't mean you should undermine it. But I'm just saying, but here, even in this situation, like if you look at most questions, they have like 10 marks. Magnetism usually has like between 8 and 6. Oh, sorry, between 6 and 8. So let's try this one. Kota, so do you have do you have your own notes for for physics other than the ones that the teacher gives you?
We have in our workbook in the green book. She doesn't let us write in our book, in like our writing book.
So you don't have like your own personal notebook.
No, no, we only have that green book.
Mm. But you can make your own personal notebook.
Yeah, no.
But I know it's work, but anyway. Uh, mm, mm. So can you can you actually, you know what, you can take out your notebook now and try to define magnetic field. Or do you have those notes that I gave you in class? Sorry.
Sorry, I don't have the notes.
Mm, now I just mean like your green book. That book that you showed me where you like write your activities and stuff.
Yeah, it's in my locker.
Oh, okay. That's fine. So can can you try to to define what a magnetic field is? Just just try. I mean, the good thing about physics is that most of the words they're self-explanatory. So, what do you think a magnetic field is?
I think it's the force generated by the atoms that create a magnetic field.
Mm, generate by Mm. You can just, I think that's a more complex answer, and, but you can just simply say that it's a field describing the magnetic influence on its surrounding, or the influence of a magnet on its surrounding. Do you understand that?
Can you say that one more time, please?
A field that describes the influence of a magnet on its environment or surrounding, like, yeah.
Yes.
Because, like, I don't think it has to be that much of a complex answer. Let me just, is there a memo for this? Now I'll check the memo later. Fine. So they say, what is the general term used to describe material that are easily magnetic? Um, so in class, like, can you can you try to answer it? But I'm not sure if you know, if you know it. But did your teacher explain to you what objects that can easily be affected by a magnet are described?
No.
Actually, after you write your test, nah, can you can you send it to me?
Which test?
The one that you're gonna write,
The physics test.
the one that you're gonna write after,
The 23rd of March.
yeah, because
They don't allow us to take the paper.
you, because you know
We
I
have
would prefer,
past papers on our drive. I can send that.
you have past papers from your school.
Yes, it's on our school drive.
Oh man, like I wish I knew that, because I think I might be doing you guys an injustice by using general question papers, because I can hear like the way you define things and all that stuff. So yeah, send me those if you can, please, so we can use those instead of like these general question papers, because I don't know how your teachers are gonna set your exams.
Okay, when should I send it?
Um, even even after now, just like as soon as
Okay.
possible.
How many,
Um, how many do you want to do? Like, there's so let me just open this calendar real quick. Um, so we're gonna have a session on Tuesday, on Saturday, on Tuesday, on Saturday. Okay, I'm pretty sure that Saturday is gonna be past the 24th, the 23rd. So we might we might have to introduce a new chapter on Saturday, and then on Tuesday we're gonna move on to another chapter, obviously. So yeah, so Tuesday, Saturday, Tuesday. That's three classes. So if we can do like at least 3 question papers or 4 is fine.
Okay.
Okay. So let me just end this meeting since I Zoom is telling me that it's ended. And then I'll open up another one and we'll continue, no?